Question. Here there is a circuit. Capacitor B and C are in parallel, whereas this parallel combination is in series with other two capacitor A and D along with 9-volt battery. Let us read the question. For the given capacitor configuration, A, find the charges on each capacitor. B, potential difference across each of them. C, energy stored in each capacitor. It's a very long problem. So let us go for a path. The path is small, the journey is long. The capacitance of a parallel plate capacitor is given by a formula C equals Q by V. Q is the charge given to the parallel plate capacitor from the battery. V is the potential difference developed across the plates of the capacitor. So the energy stored in the capacitor is epsilon 1/2 CV square. Now, instead of C, we can substitute Q by V. So we'll get another formula for energy epsilon equals 1/2 QV. Then we can even substitute V as Q by C to get another formula for energy epsilon equals 1/2 Q square by C. Out of these three formula, the first formula epsilon equals 1/2 CV square will be using in this problem. Then the capacitors in series. Three capacitors C1, C2, C3 connected in series along with the battery. Now, each capacitor stores the same amount of charge Q due to induction. Then the sum of the voltages across the capacitor V1, V2, V3. If you sum up this will be equal to the voltage of the battery, capital V. So V equals V1 plus V2 plus V3. So the effective capacitance 1 by Cs equals 1 by C1 plus 1 by C2 plus 1 by C3. Then the fourth, the capacitance in parallel. So three capacitors C1, C2, C3 are connected in parallel. These plates of the capacitors are connected to the terminals of the battery. Therefore, the voltage across each capacitor is equal to the battery voltage V. The sum of the charges Q1, Q2, Q3 equals to the charge delivered from the battery. So capital Q equals Q1 plus Q2 plus Q3. The effective capacitance Cp equals C1 plus C2 plus C3. Let us start the journey. Let us first find the effective capacitor. So here in our circuit, the capacitor B and C are parallel. So Cp equals Cb plus Cc. The value of Cb is 6 microfarad, whereas the value of Cc is 2 microfarad. We are adding this value. We find Cp equals 8 microfarad. So the two capacitors B and C are replaced by a single capacitor, effective capacitor P, which is having an equivalent capacitance 8 microfarad. So now the capacitors A, P and D are in series. So the effective capacitance 1 by Cs equals 1 by Ca plus 1 by Cp plus 1 by Cd. Let us substitute the values of Ca, Cp and Cd. Let us avoid the microfarad right now to simplify the calculation. So we get 1 by Cs equal to 3 by 8 and the Cs equal to 8 by 3 microfarad. Let us bring this unit at the end, right? Cs equal to 8 by 3 microfarad. So the three capacitors A and P and D, all three are replaced by a single capacitor C, which is having equivalent capacitance of those three capacitors A, P and D equals to 8 by 3 microfarad. Let us now find the charge on this capacitor S. So the charge on Cs equal to Qs equal to CSV. Let us substitute the value of Cs. That will be 8 by 3 into 10 power minus 6. The voltage across the Cs is 9 volt. So 3 cancels the 9. We get Qs equal to 24 microcoulomb. This 24 microcoulomb will be with the other capacitors in series. That is, capacitor A and D would take the same charge 24 microcoulomb. So as CP, CA and CD are in series, each capacitor stores the same charge QS. So QS equal to QP, Q equals QA equals QD equals 24 microcoulomb. So QS equal to, we have written this 24 microcoulomb on each of the capacitor A, P and D. Let us now find the voltages across each capacitor. So check out each capacitor, they are having the same capacitance. Check out each capacitor, they are having same charge. Definitely the voltage across each of them would be same. So VP equals, VA equals, VD equals QP by CP equals QA by CA equals QA by CA equals 24 into 10 power minus 6. That is a charge available on each capacitor, and 8 into 10 power minus 6, that is the capacitance of each capacitor. So cancelling, we get 3 volt is the potential difference across the capacitor A, P and D. To find the charges on B and C. Now let us replace the P capacitor by the original combination. So 6 microfarad and 2 microfarad in parallel. The voltage across this parallel combination is 3 volt. Remember it. So now QB equal to CB into VB. The value of CB is 6 into 10 power minus 6 and the voltage is 3 volt. So the charge available on the capacitor B is 18 microcoulomb. Like that, the charge on QC, the charge on C, QC equal to CC into VC. 2 into 10 power minus 6 is a value of CC and V is 3 volt, that is equal to 6 microcoulomb. So QB equals 18 microcoulomb, QC equal to 6 microcoulomb. Let us find the energy stored in each capacitor. So we know that epsilon A equals 1/2 of CA VA square. So we know the value of CA as 8 microfarad. We know the value of VA, that is 3 volt. Substituting that, we will be finding the energy stored across the capacitor A equals 36 microjoule. So similarly, the energy stored across the capacitor B equals 1/2 CB square. The value of CB is 6 microfarad. The voltage across B capacitor is 3 volt. So epsilon B equal to 1/2 times 6 into 10 power minus 6 into 3 into 3 equals 27 microjoule. Let us go for the third one. The energy stored in capacitor C equals 1/2 CC VC square. So let us substitute the value of CC as 2 microfarad. Let us substitute the value of voltage across C, that is 3 volt. We get the energy stored in capacitor C equals 9 microjoule. Finally, let us find the energy stored across the capacitor D equals 1/2 CD VD square. The value of CD is 8 microfarad. The voltage across D capacitor is once again 3. So we'll get the energy stored across, the energy stored in the capacitor D equals 24 microjoule. Thank you.